My name is Jayavardhana VR and my index number is 230299D. This presentation is about my proposed design for a bench scale adjustable speed pottery wheel. The main objective of this project is to design a compact, affordable and user-friendly pottery wheel that can provide adjustable speed, smooth rotation and enough torque for small scale pottery work. The design mainly focuses on machine element design principles such as belt drive, worm gear reduction, shaft support, bearing, flywheel effect and structural stability. Pottery work needs different wheel speed for different operations. For example, low speed is useful for centering and finishing, while higher speed is useful for shaping and forming clay. In many low-cost pottery wheels, speed control, torque, stability are limited. On the other hand, professional pottery wheels provide good performance, but they are expensive and larger in size. Therefore, this design focuses on a middle-level solution. The target users are students, beginners, hobby users, and small workshops. The design goals are to create a compact bench scale structure, keep the design affordable and practical, provide adjustable speed and smooth rotation, and make the wheel easy to operate. This slide shows the key design features included in the proposed pottery wheel. The main feature is adjustable speed, which allows the user to control the wheel speed according to the pottery operation. The design also includes both side rotation, so it can rotate both clockwise and anti-clockwise directions. A flywheel is added to improve smooth rotation. Rubber foot pads are used to reduce vibration and improve stability. A water removing bucket with a drain tap helps with cleaning. The design is compact for bench scale use. The two important innovative features are centering assist system and the load adaptive speed stabilization system, which improve usability and performance. The proposed design uses a compact frame that supports the motor, belt drive, gear system, vertical shaft, wheels head and water tray. The overall arrangement is shown using both sketch and 3D design. The electric motor is placed at a lower part of the frame to reduce the center of gravity and improve stability. Power from the motor is transmitted through a belt pulley system, then through a worm and wheel gear arrangement. Finally, the vertical shaft rotates the wheel head. This arrangement allows the high motor speed to be reduced into suitable low speed, high torque output for pottery work. The drive mechanism is one of the most important part of this design. The motor first rotates the motor pulley. This pulley drives the belt. The belt transfers power to the larger driven pulley. Since the driven pulley is larger than the motor pulley, the speed is reduced and torque is increased. The driven pulley rotates the horizontal input shaft. This is fixed to This shaft is connected to worm gear system. The worm gear measures with the worm wheel, which is fixed to main vertical shaft. This changes the power transmission direction from horizontal to vertical. The wheel head is mounted on the vertical shaft, so it receives smooth, reduced speed rotation and higher torque. The adjustable speed feature is necessary because pottery operations do not use only one fixed speed. During centering, the user may need slower and more controlled speed. During shaping, a slightly higher speed may be useful. In this design, the motor speed controller allows the user to select required speed. The belt and worm gears reduction system then helps to bring the final speed into suitable pottery range. This gives better control compared with simple fixed speed wheel. This also improves safety. because the user can start because improve safely because the user can start at a lower speed and gradually increases the wheel speed without disturbing the clay. The flywheel is added to improve the smoothness of rotation. In pottery work, the user applies different amount of hand pressure on the clay. This can cause small speed changes or jerky motion. The flywheel helps to rotate. The flywheel helps to store rotational energy while the wheel is spinning. When the load changes suddenly, the stored energy helps the wheel to continue rotate smoothly. This reduces speed fluctuations and improve the final shaping quality. Therefore, the flywheel supports stable operations, better control and smoother user experience. The shaft, bearing and coupling are important for reliable power transmission. The main vertical shaft carries the wheel head, the flywheel and the worm wheel. Because of this, it must resist twisting, bending and vibration. The horizontal shaft carries the pulley and transfers motion to the gear system. Bearings are used to support shaft and reduce friction. In this design, bearing support helps preventing wobbling of the wheel head and allows smooth rotations. Coupling or proper shaft connections are also needed to avoid slipping and transfer power safely between components. The frame is designed to be rigid and stable because pottery work involves hand pressure. If the frame is weak, the machine may vibrate or move during operation. The lower motor position improves balance while the rubber foot pads reduce vibration and prevent sliding on the workbench. Safety is also important because belt, pulleys, shaft and gears are moving parts. Therefore, the design includes safety cover areas to protect user from the accidental contact. The water bucket and drain tap also help separating clay and water from the mechanical parts, improving cleaning and durability. This slide highlights the main innovative features of the proposed design. The first innovation is the beginner-friendly centering assist system. Centering clay is one of the most difficult steps for beginners. If the clay is not centered correctly, the flywheel may vibrate and final product may become uneven. To solve this problem, the design includes a removable or liftable assist arm with the soft rollers. These rollers gently guide clay toward the center while we rotate at a lower speed. This reduces beginner error and improve confidence and make the pottery wheel more suitable for learning and training purposes. The second innovation is load adaptive speed stabilization system. In a normal pottery wheels, the speed may be decreased when the user applies hand pressure or when the clay load increases. This can affect shaping accuracy. In this system, an RPM sensor detects changes in wheel speed. A PWM controller then adjusts the motor power automatically to maintain stable speed under change in load. This helps the wheel continue rotating smoothly and improve control during shaping. Together, these two features make the design more than a basic adjustable speed pottery wheel. The centering assist system supports the user while the speed stabilization system supports the machine performance. Combined with mechanical design, these features improve usability, stability, safety and shaping accuracy. In conclusion, the proposed design is a compact bench scale adjustable speed pottery wheel suitable for students, beginners, hobby users and small workshops. The belt and worm and wheel gear reduction system reduces motor speed and increases torque, while the flywheel and bearing supports the shaft provide smooth rotation. The design also include both side rotation, rigid frame support, rubber foot pads, safety cover areas, and a water removing bucket with drain tap. The addition of beginner-friendly centering assist system and load adaptive speed stabilization system make the design more innovative and practical. Overall, this pottery wheel provides a good balance between performance, cost, stability, safety, and ease of use for small scale pottery applications. Thank you.